Today, no new car hits the showroom without being rammed into walls, barriers, and other automobiles to make sure you're safe in your vehicle. Initially, crash test sites focused on what happened inside the car. But drivers and passengers aren't the only victims of crashes. Pedestrians are often involved in serious accidents, and they don't come with airbags. But how do you make cars safer for people walking down the street? You do pedestrian crash testing. It's research so cutting edge that there are only a handful of testing facilities in the world. Here at Honda R&D Americas in Raymond, Ohio, these guys have been studying pedestrian collisions for 5 years. It's the major focus of their crash test site. The man in charge of the pedestrian crash test is Honda's automotive safety testing specialist, Brad Arn. Brad and his team work with a highly specialized dummy, designed just for Honda. They spent $1 million developing the prototype. Each Polar 2 costs $300,000, and only 3 exist in the world.
The Polar 2 dummy actually has a knee that has 4 ligaments in it, just like a human knee. It has a tibia that's kind of consumable, that's replaceable in between tests if it is to break. The ribs actually use a different type of sensor than a normal dummy. The arm has better range of motion. It's just more anthropomorphically correct than an actual dummy that you'd use in a frontal collision.
The Polar 2 may be the most evolved crash test dummy in history. And Brad and his team are getting ready to run theirs over with a big SUV. Today, their concern is preventing you from being killed by head injuries. They're focusing on where the bumper is placed and the shape of the hood.
So what's going to happen is the Acura MDX is going to start down about 90 meters down the tunnel. We'll hook it up to the cable and get the cable in the car going up to 40 kilometers an hour, and it'll hit this trigger on the floor, releasing the magnet.
1 meter from impact, the car will hit the trigger. Everything is calculated so the dummy will be standing still at the moment of impact.
The dummy does not have any time to actually come down or move. From the time the dummy is released to the impact is about 30 milliseconds. That's 30 thousandths of a second. It's that quick.
The exact position of the dummy at the time of impact is crucial.
The goal is to get him in the same position each time so our results are repeatable, so that we can make effective countermeasures based on repeatability.
Cameras are ready, fence ring's ready, lights are ready.
All right, give me a countdown.